Hello everyone, welcome to topic 3.7, solutions and mixtures. By the end of this, you should be able to calculate the number of solute particles, volume, or molarity of solutions. I am going to add one equation to this, and that is the dilution equation where M1V1 is equal to M2V2. And this is a derivation off of the molarity equation over here, where molarity is the moles of solute over liters of solution. Okay. So solutions come in the form of solids, liquids, and gases whose macroscopic properties do not vary. So that means that these are homogeneous mixtures. If I could spell, sorry guys. For liquid solutions, the solute may be a gas, so like carbon dioxide dissolved in water, a liquid, so like ethanol or ethyl alcohol and water, or a solid, so if you dissolved salt into water. While there are many different methods for describing the solution concentration, molarity is the most common concentration measure used in the laboratory. So if you go on to like med school or something, especially med school or nursing school, they use a lot of molality or parts per million or units per certain amount of volume. So there are different ways to express solution concentration. The one that we deal with in this class is molarity, which has units of moles per liter. Okay, and you want to remember this equation. Okay, and so when we're trying to figure out what the molarity of something is, we can take the moles divided by the total volume of solution. The properties of liquid solutions: the components cannot be separated by filtering. We will see that you can use distillation or evaporation to do this though. There are no components large enough to scatter visible light. So there's no like bigger solid chunks that'll cause the light to scatter. And the components can be separated using processes that result as a result of intermolecular interactions. So this includes distillation, chromatography, and others. And we'll come to chromatography in a separate section. I think distillation also comes up later on as well. Okay, so ion concentration. Ionic compounds dissolve into ions when they form solutions. So this is called dissociation, right? So they dissolve, they dissociate. They no longer associate with each other, they separate, and that's called dissociation. Because of this, the concentration of the ions found in a solution of a given concentration may not be the same as the original solution. For example, while 1 mole of sodium chloride, NaCl, will dissolve in water to form 1 mole of sodium ions and 1 mole of chloride ions. 1 mole, and it should have been shown below, but I don't know where the picture went. I'm sorry, guys. 1 mole of calcium chloride, which is CaCl2, forms 1 mole of calcium ions and 2 moles of chloride ions, and that's from the chemical formula for calcium chloride. Because of this, a 1 molar or molarity solution of calcium chloride contains 1 mole of calcium ions but 2 mole of chloride ions. Therefore, the chloride ions are twice as concentrated or have twice the molarity in the solution. So when the things dissociate from each other, right, so they split apart, for every 1 compound I get 1 calcium ion, but I get 2 chlorides. Okay, and the difference here is that over here you would have a 1-to-1 ratio. So you'd have half as many chloride ions. Okay, so when we dissolve and we look at the ratio or concentration of ions, it's going to be based off the chemical formula. So you need to pay attention to your subscripts. So I have 2 to 1. That means that we have a 1 calcium to 2 chloride ratio. Okay, so let's look at how we can apply that. So we're going to calculate the volume of a 1.25 molar lithium chloride solution that can be made with 13.3 grams of lithium chloride. So if we have the 1.25 molar solution, but we are given 13.3 grams, it wants us to know what volume. Okay, well, we know molarity, and we know the equation is molarities is equal to moles over liters, or mole over liter, N being mole. Well, we want to know this. This is what we don't know. We know molarity, so we need to find moles before we can calculate the volume. Well, we're given grams of lithium chloride, and we know that using stoichiometry we can change this into moles of lithium chloride, which is what we can then use here to solve for the volume. So we're going to do that. So 13.3 grams of lithium chloride, and we want to convert it, so that means that we put grams on the bottom so that the units cancel out, and we want moles, so moles goes on top. The ratio between grams and moles is called the molar mass, which states that for every 1 mole of a substance, they have a mass that is related to their atomic masses on the periodic table. So 42.42 grams is the molar mass of lithium chloride, because that's 6.93 or some. The mass of lithium from the periodic table plus the mass of chloride, add them together and you should get 42.4. When you do this math, you multiply across the top, which is boring, and dividing by the bottom cancels your grams, so 13.3 divided by 42.42 is 0.314 moles of lithium chloride. So now we know moles, we know molarity, we can solve for liters. We want to rearrange this equation so that liters is by itself, so cross multiply, and you have molarity times liters is equal to moles. Then divide by molarity, so liters is on its own, and so we have liters is equal to moles divided by the molarity, which when we substitute in, our moles that we just calculated goes on top, and then our molarity of our solution goes on the bottom. And so our final answer when we do this math should be 0.251 liters. And so that should be the total volume of the solution that we would need to make this. Okay, our next one, what would be the concentration of the chloride ion in a solution that is made by dissolving 10 grams of zinc chloride in a solution that has a final volume of 50 milliliters? Well, molarity, remember, is moles over liters, so I need to make sure I have both of those. Well, I have an amount, but it's 10 grams, so I have to change that into moles. And then I need liters, but I have milliliters, so I need to change that into liters. So we're going to start with moles, changing something into moles. So 10 grams of zinc chloride. And then we're going to change it into moles, so that means that we have zinc chloride grams on the bottom and moles on the top, so that the units end up canceling out. 1 mole from the periodic table has a molar mass of 136.28 grams. And then we divide by what's on bottom and units cancel, and you should get 0.074 moles of zinc chloride. Okay, so we've got our moles. Now we need to find our liters. So 500 milliliters into liters. 1 liter is 1,000 milliliters. And now you probably could just move the decimal point for that. but you should end up with 0.5 liters. 0, 0 because they made a distinction that it has 3 sig figs. Now we're ready to calculate our molarity, which is moles. So this one, 0.074 moles over liters, which is 0.500 liters. And we should get 0.147 molar zinc chloride. Now we need to change it to just chloride, so we use a ratio. So for every 1 zinc chloride, I have 2 chlorines, so I could put 2 chlorides. And so when I do that, I switch my units, and I should get 0.294 molarity because my units don't change, but my substance did, because chloride ion is twice as concentrated because there are 2 released when the solution dissolves and the ions dissociate. Okay. Continuing on, we're going to look at our we-dos. So how many grams of potassium hydroxide would be dissolved in 250 milliliters of a 0.1 molar solution of potassium hydroxide? So we want to know grams, okay, and we have our volume, or a way to get liters, and our molarity, right? So to get to grams, we first have to get to moles, and then we can go to grams. So using the 2 given values, figure out how many moles, and then convert it to grams for potassium hydroxide. Please pause the video and complete this now. Okay, so you should have attempted this. The first thing you should have done is convert volume into liters. Once you have done that, you are going to rearrange the molarity equation to solve for moles. So that way you know you need to multiply molarity times liters, and that gives you moles of potassium hydroxide. Then dragging the units diagonal and putting grams on top, because that is what you were asked for. The grams to mole ratio is the molar mass, so 1 mole of potassium hydroxide has a mass of 56.11. Multiplying across the top and dividing along the bottom to cancel units, you should end up with 1.4 grams of potassium hydroxide. Okay, so now we're going to look at the next one. What is the nitrate ion concentration? So we want to know the molarity, but of the ion, in 100 milliliters. So that is a volume of magnesium nitrate solution that has 2.5 grams of dissolved magnesium nitrate. So this is going to be similar to question 2 in the I do, where we do need to convert the final concentration of magnesium nitrate into just nitrate using a ratio. But first, we know that the molarity equation requires moles and liters, and if I'm looking for concentration, I have to start there. So I have volume, which is liters, but I need to change my grams into moles, and this also into liters. So starting with that, convert the 2, determine molarity of magnesium nitrate, then use a ratio to determine the molarity of just the nitrate ion. Please pause the video and try this on your own now. Okay, so your first step should have been to convert to liters and then to moles, giving you a volume in liters and your amount of your solute in moles. You can then substitute it into the molarity equation, and that gives you molarity of the magnesium nitrate solution. You can then use a ratio to solve for the molarity of nitrate, which it should be twice as concentrated because there are 2 nitrate ions for every 1 magnesium nitrate compound or formula unit. Okay, and so you should get 0.34 molar nitrate ion. So using this information, these 4 examples, you are going to complete the you do questions through 6. Okay, check your work, have it done. Thank you guys.